Good morning. Today we are going to say up-down counter. In previous classes we have seen up counter, down counter. Today this counter can be used for upward, that is ascending order counting, as well as descending order counting. Up counter means 0 to n. Okay, up counter means 0 to n. Down counter means n to 0. Okay, here we are going to use, that means you are going to design up down counter. Either you can use up in one direction one time or down in one time, just like a parallel adder circuit. You can add one time or subtract one time. Okay, it is a device. It can be used for two purposes, one for addition, one for subtraction. Just like here, it can be used for either in upward direction or in a downward direction. Last class we have designed up counter and down counter using JK flip flop. Okay, using JK flip flop. In JK flip flop, which condition we have used? We have used JK flip flop in a toggle condition. Okay. If you have forgotten this, just go through earlier video. That means up counter and down counter. Okay, using JK flip flop. Okay, JK flip flop, which is in a toggle position. That means it is connected to 1. That means high state. It is connected to high state. Okay, and it is negative triggering, negative clock pulse. Okay, CP is negative. In up counting, we have used Q is connected to the next clock pulse, and down counter we have used Q bar to the next clock pulse. Okay, I will write again. For up counter, in last class, up counter, Q is connected to next CP clock pulse, and down counter Q bar is connected to next CP. Okay, that means for one type we are using Q, for another type we are using Q bar, but in both the cases output is drawn from Q only, not Q bar. Okay, you have to connect Q or Q bar to the next clock pulse. Now we are going to use up down counter. That means we have to use both Q and Q bar at one time. We have to use both Q and Q bar at one time. Now how is it possible? In a bidirectional register, you might have remembered, in bidirectional register, I have shown you this type of smiley face. This type of smiley face. That means 2 AND gate, 1 OR gate. Here also you are going to use this type of 2 AND gate, 1 OR gate. For simplicity, I am going to do this circuit design for 3-bit only. In last class I have done for 4-bit. Now I am going to do for 3-bit only, because due to the size of the board. Okay. In exam also you can design for 3 bits, because 4 bits means time will be more and paper capacity will be more. Okay, it is a lengthier diagram. Therefore, you can reduce the diagram for 3 bit, and you can write this can be extended to n number of bit. If you know the principle, then you can extend to n bit. Okay. Now, how to use this? Now, here connect one AND gate. Okay, and here another AND gate. This Q is connected here and a Q bar is connected here. Okay, for an upward Q is required, for downward Q bar is required. Now it is up down, therefore both are required. Therefore Q and Q bar are connected to the AND gate, and one OR gate is required. Okay, and connect this AND gate to the OR gate, this AND gate to the OR gate. Okay, and this OR gate should be going to the next clock pulse. Okay, again the same principle. Okay, while drawing the diagram, okay, please remember you are connecting here. One more terminal we are going to use. Therefore, you connect this Q to the second place like this. If you connect here, then it will be difficult. Therefore, while drawing, you have to note how I am drawing. Okay, here I have drawn little higher. Okay, therefore I have connected to the lower end, not to the upper end. Here I have connected to the upper end of the AND gate. Okay, now here Q bar is there, connect Q bar, and again one OR gate. Okay, and here connect this OR gate and connect this OR gate. Okay, and it is going to the next clock pulse. Here Q and Q bar is there, Q and Q bar is there. You can extend here n number. Okay, just another AND gate, another OR gate like this. Now for this up counter, I am telling, for up counter, this AND gate should go to, now I am removing this, deleting, erasing. Okay, this AND gate and this AND gate. Okay, if you keep both the AND gates in one, then only this AND gate and this AND gate will work. If you give a clock pulse, now this AND gate, if it is 1, it will respond for this output. If this AND gate is 0, that means this input is 0, then this AND gate will not respond. Okay, I will explain after the complete connection. Okay, now this AND gate and this AND gate are connected together. Both are connected together. Okay, this AND gate are connected together. Now this terminal and this terminal are called control terminal. Okay, both this and this are control terminal. Now how to connect both these? By means of a simple NOT gate only. Okay, now listen. Now this is the one. Now you are connecting this. Okay, here. Now you are connecting this here through a NOT gate. Okay, both the control terminals are connected through a NOT gate. Now if it is 1 means this terminal is activated and it is 0. That means I will name it here 1, 2. Okay, if this is 1, okay, then it is upward. Okay, up counter. If it is 0, that means up counter means 1. If you give 1 means AND gate 1 and 2 are enabled. Now let us check. If you give a CP here, 1 clock pulse you are giving, then already JK is in toggle condition. Okay, JK in toggle state. That means Q and Q bar will toggle. Now depends on, if for example if it is 1, then this is 1 and this is 1. This AND gate will respond. Therefore this will go to OR gate. And depends upon this and this, it will respond or it will not respond. Therefore here this will respond or will not respond according to this input. Now it is going to the next JK flip flop and then further it is going. Now for example if it is 0, this AND gate 1 and 2 will not respond. Now this 0, that means down. Now it is down. I am writing again. Okay. Now 0 means down. Okay. 1 means up. Okay. Now 0 means this AND gate 1 and 2 will not work and 3 and 4 will be enabled. That means Q bar will be, output of Q bar will be going to the this AND gate and this OR gate and to the next clock pulse. Already we have seen for up counter Q is connected to the clock pulse. For the down counter Q bar is connected to the clock pulse. Now both are connected to the clock pulse, but we are using either Q or Q bar according to for our purpose, whether we are using up counter or down counter by this control terminal. Okay, by this control terminal. Now this is the control terminal. Okay. By this control terminal, you are using one device as up counter as well as down counter. In a class, I have asked, can you give an example for up counter, down counter? Then one smart student answered, while you upload a video, for example, I am uploading this video after the class, okay? While uploading video, then your uploading process, okay, is percentage is increasing, 5%, 7%, 100% like this. And my timings, for example, 1 hour, it is reducing, 1 hour, then 45 minutes, okay, and then just like it is go on reducing. That means in that bar I am seeing up counter as well as down counter, okay, but here you can use either up counter or down counter, okay. That means it might be connected to counters, one for uploading process and another for timing, and both are synchronized, okay. Here understand this, we are using JK flip-flop in a toggle mode and we are connecting Q and Q bar. Q is connected for up counting and Q bar connected for down counting and to the clock pulse, but one at one time only, and depends upon this 1 or 0, it is used for up counter or down counter, okay. If you don't understand, you have to go for this up counter circuit connection and then down counter circuit connection, and then you can easily understand how this circuit is working. In exam, you have to draw this circuit connection as well as you have to draw the truth table for up counter, okay, and a truth table for down counter, okay. Then only you will get a full mark. Thank you very much. If you have any doubt, please drop in a comment box. Thank you.